Okay, good morning and welcome back to the Mat-Su Salmon Science and Conservation Symposium. Thank you everyone for making the time to join the symposium today. So I'm Laura Eldred with the Alaska Department of Environmental Conservation, and I'll be moderating our first session of excellent presentations. So I'll draw your attention to the symposium booklet that has presentation abstracts, as well as presenter contact information. But first, just a few logistics. I'll introduce each presenter before the presentation. And similar to how we just did with the keynote, please type your questions into the chat box during the presentation or right after, and then I'll moderate the question and answer period after each presentation as time allows. So, using sound science to help inform resource management and decision-making is a core element of the Mat-Su Salmon Habitat Partnership. So in this session, we'll have 3 science-based presentations to further our understanding of salmon and their habitat. The first presentation is titled Spatial Patterns in Thermal Regimes Across the Little Susitna and Deshka Watersheds, and Linkages to Temperature Requirements for Salmon. This will be given by Rebecca Shaftel, an aquatic ecologist from the UAA Alaska Center for Conservation Science. So again, please utilize the chat box. And Becky, we're eager to learn about your team's research, and the floor is yours.
Hi, everyone. My name is Becky Shaftel. I work at UAA, and I'm going to go ahead and start my presentation. Laura, can you see that okay?
Yes, looks great.
Great. I'm here to talk about thermal regimes in the Little Susitna and Deshka watersheds, which are 2 important salmon-producing rivers in the Mat-Su Basin. And I will be linking stream temperatures recorded there to salmon. I want to acknowledge my collaborators are Sue Mauger with Cook Inletkeeper and Dan Ranella with the U.S. Fish and Wildlife Service. Stream habitats in the Mat-Su Basin are really diverse. The basin's defined by the large glacially fed Matanuska-Susitna rivers, but there are also many other stream habitats that span different stream sizes and different elevations. They receive different types of hydrologic inputs, such as snowmelt and groundwater and precipitation. And all these different characteristics combine to produce different stream temperatures. These box plots are showing maximum summer temperatures from a large data set we've been collecting for a lot of southern Alaska. I wouldn't put too much into the differences between these different subbasins because that's really based on where we've been collecting data. But you can see in the lower Susitna River, where we have a lot of access, we see a really wide variation in maximum summer temperatures. And now I'm overlaying actually summer temperatures that we recorded, or different scientists have recorded in 2019, are really anomalously warm summer a couple of years ago. This is also a little bit biased because this has 80 sites from the Deshka watershed, which I'm going to tell you today is a really warm system. But the point I want to make here is just that there are still several streams that are actively being monitored where, even though air temperatures were in the 90s that summer, their stream temperatures stayed relatively cold. And that's probably because of diverse hydrologic inputs like glacial meltwater or groundwater. So we can use what's called a stream thermal regime to better understand stream temperatures and their impacts to salmon. And so a thermal regime captures things beyond just maximum summer temperatures. We can use stream temperature metrics to look at the frequency of warm temperature events or the duration of those warm events. We can look at the timing of different cold or warm temperature events, and that can be really important if you're trying to intersect stream temperatures to biology. And then finally, it's really important to think about variability in stream temperatures over different temporal scales. So the objectives of this analysis were to describe and compare thermal regimes in the Deshka and Little Susitna River basins. And this is building on a previous project we completed a few years ago for the Mat-Su Salmon Habitat Partnership, where we classified stream thermoregimes across different stream habitats spread out all across the basin. And so this is building on that work by looking at thermoregime diversity for monitoring sites within these two important watersheds. And in the Deshka, there are about 80 monitoring sites, and in the Little Susitna, we have about 30 monitoring sites. And then secondly, I want to link temperatures to salmon life stages and evaluate their interactions with adult migration, embryo incubation, and juvenile growth. So this figure is showing average summer air temperatures for the Mat-Su Borough over the last 40 years. And then that horizontal line is just the long-term average over that same period. And this is just to show you, the few years of data that we have for each watershed. In the Deshka, we have 2017, 2018, and 2019. So we do have one very warm year captured. And for the Little Susitna, we have data for 2016, 2020, and 2021. So again, we do have a warmer than average year for the Little Susitna as well, and that was 2016. Now I just want to tell you about the 4 different thermoregimes that we developed from our classification. Starting with the cold thermoregimes, we defined a cold stable and a cold variable thermoregime. So for both of these, if you look at the top left, maximum summer weekly temperatures are pretty cold in these 2 types. And the difference is that the cold stable has more stable temperatures over the summer versus the cold variable. But then additionally, if you look at the box plots in the top right, there's a later timing of cold variable of maximum temperatures for the cold variable thermoregimes, and that's due to snowmelt inputs in these stream habitats. And then we define 2 warm thermoregimes, warm variable and warm long. So again, looking at maximum summer weekly temperatures, both of these are much warmer, warm variable on average close to 20 degrees, and warm long on average are above 20 degrees Celsius. And then these 2 thermoregimes can be differentiated by the duration of temperatures. This is the longest temperature event during the summer, greater than thresholds that are important for protecting different salmon habitats. So 13 degrees is the threshold that's recommended that salmon habitats that are providing adult spawning and early incubation stay below. And you can see that warm variable thermoregimes on average might be above this threshold for a couple months over the summer, but warm long thermoregimes are really above this threshold for most of the summer, which would be most important for summer spawning salmon like Chinook. And then finally, the warm long thermoregimes in the bottom right stay above this threshold of 18 degrees, which is protective of migrating adults and juvenile rearing juveniles, and they stay above this threshold for on average for about 3 weeks each summer. So these maps are showing predicted thermoregimes using the monitoring data collected in the Deshka River watershed. And the 3 panels on the left are from main stem habitats. And then the 3 panels on the right are from tributary habitats. And we basically found a pretty similar pattern across both main stem and tributary habitats, where in more normal summertime air temperatures, in 2017 and 2018, a lot of the Deshka is providing warm variable thermoregimes, and then there's some diversity, some cold variable and cold stable thermoregimes. But all of them shifted very much to warm long thermoregimes in 2019. There were some new sites that were monitored in 2019, some tributary sites for juvenile salmon, and so that's where you see some new sites pop up that actually didn't respond as strongly to those warm air temperatures, and they were, a couple of cold stable thermoregimes you can see there. In the Little Susitna watershed, main stem habitats or monitoring sites are on the top, and tributary monitoring sites are on the bottom. You can really see, especially in the main stem, that the Little Susitna is really dominated by cold variable thermoregimes. So that makes sense based on what we know from our previous work, that these are really the snowmelt dominated thermoregimes, and because the Little Susitna is draining high elevation mountains and Hatcher Pass, we receive snowmelt and even a little bit of glacier melt. these habitats are really mostly cold variable in normal years. But then we see a shift again in the warmest year that we've monitored in the Little Susitna in 2016, that below the Parks Highway, the main stem and the tributary habitats were more likely to be warm variable. And then we had one tributary we've monitored all 3 years, and in the warmest year, it became a warm, long thermal regime. And that tributary is draining a lot of lake and wetland habitats. So now shifting over, we wanted to look at these temperatures and how they could be affecting different salmon life stages. This plot is showing in black daily counts of migrating adult Chinook salmon into the Deshka River, and the blue is showing the stream temperatures in the Deshka River. And you can see that as temperatures were climbing up in late June and hit 20, that adult salmon really stopped migrating into the river and were holding in the main stem Susitna River where it was colder. And it wasn't until temperatures really cooled and dropped again that you really see that last pulse of migrating Chinook salmon moving into the river. So stream temperatures are also really important for controlling incubation times, or development times rather, of incubating embryos. So we looked at stream temperature data from monitoring sites that were identified as spawning habitats in the Nadromus Waters catalog. And we calculated emergence timing for fry from these different watersheds. And you can see that in the Deshka, that emergence timing is earlier than in the Little Susitna, which makes sense because the temperatures are warmer. But you also see a difference in the 2 years. So we had 2 winters of data we could run these models for in the Deshka. And you can see that in spawning year 2018, that fry emerged approximately 3 weeks earlier. And so on the bottom, I'm showing temperatures from a site that sort of showed those median values for the 2 years. And you can see what's happening here is that temperatures are staying warmer for longer into the fall. And then in the spring, temperatures are warming faster. And so that's like a very common understanding of how climate change is warming things in Alaska. Freeze up is occurring later, snowmelt is occurring earlier. And so how this might possibly impact juvenile salmon is really unknown. If earlier emergence could cause a mismatch with food resources if invertebrates don't advance at the same rate as juvenile salmon emergence advances, or it could, if food resources aren't limiting, it could allow for a longer growing season and larger salmon sizes entering habitats the next winter. So finally, we looked at stream temperature data and how it might impact juvenile salmon growth. And I'm showing 2 temperature metrics here. On the y-axis, I'm showing average daily range. So the daily range is the maximum temperature for a day minus the minimum temperature. And then this is the average for the month of July. And then on the x-axis, I'm showing the mean monthly temperature. So I'm showing these 2 temperature metrics because they were shown in some modeling work conducted by the Fish and Wildlife Service to affect juvenile salmon size based on data collected in 2019 and 2020. And they basically found that capture probabilities were higher in were highest in habitats at 16 degrees Celsius, which I'm showing here with the vertical line as a thermal optimum. And then they also found that daily range had a negative effect on size in July of 2019. And so you can see here in the Deshka watershed, each of these points is a monitoring site. And then I've outlined in black the years from 2019 in the Deshka and the Little Susitna of 2016. But the point here is just that there are lots of habitats in Deshka, especially in 2019, that are potentially above optimal. But then we also see habitats that have really high daily range. And this really high daily range, even when they're below optimum, could lead to decreased growth just because you're starting to have temperatures that now are above optimal when you have such a large daily range. So in conclusion, what we found was that warm temperatures led to lower thermal diversity in 2019 in the Deshka watershed. And you can see that in these final box plots, that in the Deshka River, there was higher thermal diversity across the 4 classes in 2017 and 2018, but in 2019, it really shifted to become warm, long thermal regimes. In the Little Susitna watershed, we actually saw most of the habitats were cold variable in 2020 and 2021, and we actually saw higher diversity in 2016, which was the warm year in the Little Susitna. So really streams and river basins are going to be responding to warmer air temperatures differently. In 2019, we specifically saw blockage of adult salmon migrating into the Deshka, and we also saw negative effects of temperature on juvenile salmon growth, both of which could indicate that this transition to warm, long thermal regimes could be detrimental to salmon. And finally, we just want to emphasize that conservation of diverse thermal habitats can promote resiliency in salmon populations in a changing climate. By having diverse thermal habitats, salmon can track optimal temperatures, and they also will have options for avoiding thermally stressful conditions. The Fish and Wildlife Service is partnering with several agencies to continue this work, looking at temperature effects on salmon in the Deshka. They're going to be working with USGS to examine juvenile and adult Chinook salmon heat stress. They're working with Fish and Game to conduct adult telemetry to identify both the spawning distribution and the timing of spawning for adult Chinook salmon in the Deshka. The Conservation Genetics Lab is evaluating eDNA effectiveness for monitoring juvenile salmon presence in the Deshka. And then finally, we are continuing our partnership with the Fish and Wildlife Service and Cook Inletkeeper to monitor temperature and juvenile salmon in both watersheds and make additional comparisons. I'd like to thank all of the staff that have been collecting all of this temperature and juvenile salmon data. And there are many, many more people and technicians that have helped both of our organizations, and especially the Mat-Su Basin Salmon Habitat Partnership for funding the fieldwork in the Little Susitna watershed.
Thank you, Becky. That was really excellent information. We do have just time for maybe 1 or 2 questions. If people have questions, please put them in the chat box. Don't see any yet. Here's one. So Becky, are there plans to field verify the model predicted emergence timing? Oh, you're muted. Can you unmute, Becky?
Oh, sorry. Thanks for that question. No, we don't have plans to verify that at this time.
And Becky, can you explain a little bit about the plans for the eDNA study, or who someone could contact about that?
Yeah, I would contact Dan Ranella with the Fish and Wildlife Service. I'm sure he can explain it.
Great, thank you. So we are going to move on to our second presenter. If there's time at the end of the session, we'll open it back up to questions for all the presenters. So just keep that in mind.